Okay, good evening. And this is Mamu with Jarvis, and more like a prequel to the concepts we're going to be starting tomorrow, which is called the Midnight Sun. To get this synopsis on, I have a problem on the board, and it's testing your knowledge of matrices. Matrices can be, is actually grade 12 work, and it's something we can find in maths and we can find in further mathematics. So I have worked with the paradigm that this is pure maths, which is essentially further mathematics. Further mathematics is divided into three aspects: pure maths, vectors and mechanics, and statistics and probability. So, but this is also an aspect of if it were pure maths, then we may want to consider this as maybe possibly if it's maths, algebra, or possibly of numerical processes, but let's see how it goes. It says, find the values of X for which the following matrices have no inverse. Now, if a matrix does not have an inverse, it means that the determinant is 0. If a matrix does not have an inverse, it means that the determinant is what? 0. So what that means is that for question A, we're going to have X, 7, they are all treated as individual elements to, this is a 2 by 2 matrix, will be equal to what? 0. That's what it means. So, and if you don't get this idea, you may not be able to solve this question. The next thing we do is the concept of cross multiplication. This will multiply this will give me 2x. This will multiply this will give me what? Minus what? 56, if I write with that. And that will be equal to 0. So what means that 2x minus 2x will be equal to 56, and x will be equal to 28. So that takes care of these this particular problem. Now for B, how does that go? It will be x minus 2, 2, 1, x minus 3. This invariably will be equal to what? 0. So how do we solve this? This will mean that what? This times this, x minus 2 into x minus 3. 2 times 1 will give me what? 2 times 1 will give me 2, and that will be minus 2 equal to what? 0. Because we said that the determinant will be equal to what? 0. So we will open this one up. And I trust you've already learned how to do this. So this will be x. Let's get another marker. This will be x multiplying this bracket, x minus 3. This will be negative 2 multiplying this bracket, minus 2 equal to 0. So this will be x squared minus 3x minus 2x plus 6. Minus 2 equal to 0. What does this give me? This will be x squared minus 5x plus 4 equal to 0. So my concept of factorization, which is something you can watch on my YouTube channel, Mamu with Jarvis, you discover that this negative 5 will mean that I need 2 factors such that when I add them, I'm going to get negative 5. But when I multiply them, I'm going to get what? 4. The plus here will suggest that the 2 factors I'm looking for will either be both plus or both minus. But because this is negative, I'm going to use 2 factors that are negative. So let's go back to 4. 4 is what? 4 times 1. If I introduce negative, I'll get a factor. So this will be x minus 4x minus x plus 4 equal to 0. So I can factor what? I can factor x out. That'll be x into x, is x squared, remember x minus 4. If I factor negative out, that's negative 1 into x minus 4, and that will be equal to 0. So what that means is that I can clean the top, having solved question 1. And this will give me what? X minus 4 into x minus what? 1 equal to 0, which means that x minus 4 will be equal to 0, or x minus 1 will be equal to 0. So we can sum and say x will be equal to 4, or what? X will be equal to 1. So with this, there are two possible values for which this matrix will have no inverse. Remember I said that the matrix has no inverse if and only if the determinant is equal to what? 0. So that takes care of that problem. And then we'll go to the next one that talks about using the matrix method and its inverse to solve this problem. Now, to handle this problem, to handle this one, we have x, another marker. To handle this one, we would have that x minus 3y is equal to 2, and 2x plus 4y is equal to -1. So we're going to use the matrix equation that says, the matrix equation says that I really need to write this out as a matrix, and that would mean that what? 1, 2, -3, and 4 would relate with this other matrix, x, y, because the way the matrix works, this one will multiply this and this. This will multiply this and this. So these are actually x positions, and these are y positions. And this will be equal to what? The matrix of 2, -1. Are we seeing that? So the concept of matrix equation says that I would address this as A multiplied by X. I'll use the capital letter X to represent the matrix here, and equal to Y, which is the matrix I represent here. Now, if I use the method of matrix and inverse matrix, I cannot make this. I cannot try to make X the subject of the formula, because that's what I'm looking for. Now, a formula says that there's a formula that says that the matrix times its inverse is equal to what? 1. The matrix times its inverse is equal to 1. So if I apply that knowledge here, it will mean that A, which is this vector, this matrix here, times the inverse of x, multiplied through by A, the inverse of A, the inverse matrix of A. This will be equal to y, the inverse matrix of A. So what I'm going to have will be what? X equal to what? Y, the inverse matrix of A. Hope I got that right. Hope I got that right. Yes, I got that right. So that would be that. And let's look at this very well. What is Y? Y is what? Okay, Y is that. Y in this setup is this value, X is this value, and A is this value. So look at that. What will be the inverse matrix of A? Now, there's also something you need to remember. Maybe at this point now, I will need to claim this part of the board since you already have this information. There's something else you need to remember here. Something very important we need to remember in solving this question, that the inverse matrix of this will be equal to the inverse matrix now of this will be whatever this one, this over what? A modulus. And this A modulus will refer to the what is called the determinant. This is called the determinant. This is a determinant. This is what is called the inverse, as it were. This the inverse matrix is giving us this matrix, what you may call the cofactor matrix all over the determinant. So what is the determinant of A? So let's get what A will be. So if I come here, the determinant of A will be equal to what? 1 times 4, which is 4, minus what? 2 times negative 3, which is negative 6. And this becomes 4 minus plus 6, and that is 10. So in fixing this here, I'm going to have the inverse matrix to be equal to what? Whatever this value I'm going to get over what? Whatever this value I'm going to get over what? This is actually called the adjunct. The adjunct has over b over 10. Now, we need to get, what we need to do now is to get, what do you call it? This one now. Now, how do we get that? This will now be equal to, what is this one? Now, in true matrix arrangement, these positions don't change. So in writing this now, I'm going to have something like this, where this negative 3 and this negative, and this 2 does not change. Please watch carefully. For 2 by 2 is quite easy. This becomes 1, this becomes 4. Now, this becomes 4, and this becomes what? 1. So what will happen now is this. Remember that for these positions now, the positions will now, this is actually a negative position. So it becomes what? Becomes a positive, if I got that right, okay, these positions will change. So these 2 remains intact. These 2 remain intact. But this one will now, it's not actually plus, minus, minus, plus. That's the order. There's something else. I'll be doing an extensive video on this shortly because of my midnight experience. This is plus, minus, something they call cofactor, minus, plus. So if you look at this very well, these positions don't change. But these 2 will actually change. So this becomes plus, and this will become what? Minus. So the inverse matrix becomes what? 4, 2 plus 3, and then what? 1. So this is what I'm going to have. So what that means is that, taking from here to this point, is that I'm going to have that, what? This problem now become what? X, which is what I'm looking for, will now be equal to what? A inverse, which is this one now, which is this times this, okay, over 10, don't forget that, will now be 1 over 10. Maybe I should clean this so that we'll have more space to write this. Clean this so that we'll have more space to write here. This will actually be what? Equal to 1 over 10 of this. And so if I have x, will now be equal to whatever y is times this value of A inverse. Okay, so with that, I can clean off what I have here. I can clean up what I have here. Or let's take up to this position so that we have some space. What is x? X is what? X, y equal to this one, which is 1 over 10 of these values now. 4, 2, and then 4, 2, and then 4 minus 2, 3, and 1, and then multiplied by, let's clean this part up, multiplied by, what am I multiplying by? We're multiplying by this one now, which is what? 2 and negative 1. So what does that give you? This will now give you 1 over 10. Keep the 1 over 10 out. Remember that this one multiplied this and this. So to multiply 8, negative 4. This times this 8. This times this negative 4. This one multiplied this minus 3, minus 1. Sorry, that will be this one. So at the end of the day, what am I going to have? This will now be equal to what? 1 over 10 of what? 5 and what? -5. So we can split this now. We can split this. Remember that this is what? X, Y vector or matrix equal to what? This times this will give me 1/2. And this times this will give me what? Because remember that this is this over this. Maybe I should take a step further to write that. Take a step further to write that. I'll come to this part of my board just to try to make things clear. So this will be what? From here, I'm going to come here to be what? Equal to 5/10, -5/10, all in matrix in comparison with X, Y. You get it? So this will now give me what? Or we can come here to say this will be equal to, we should come here. This will give me what? 1/2 minus 1/2. So with that done, I'm going to have that X is half. By comparison, X will be equal to half and Y will be equal to minus 1/2. So what you do next is to check. We can check in the equation X is half minus 3 into, this is minus half. So that's minus 1/2. What will this give you? This will be half plus 3/2, and that is what? 4/2, which is what? 2. So which means that what I have done is what? Actually correct. This was like an abridged video on this work. I'm trusting that in subsequent classes, we'll be able to do an extensive work on this, right? So that's just a little solution to this. And what I'll advise you when you're copying to, if you're going to flow through as I flow. Don't say you want to wait and watch everything. Flow as I flow, and then afterwards run everything together. I'll see you shortly.